What's up guys, it's Giuliano Daniel, and today I'll be explaining to you guys in class how physics is involved in tennis. I'm going to break down the ground stroke for you, which is the most popular shot in tennis, and I'll explain how physics is involved, and I'm going to revolve around the spin of the shot and impulse, or how hard you hit the ball. Alright, so before we get started, I'm going to show you what a ground stroke is.
Yeah.
Okay, I'm going again, okay? Alright, that's good. Okay guys, so if you couldn't tell from my previous video, this is the upward view of a tennis court, and I was hitting the ground strokes right around here and here, the left side being the forehand and the right side being my backhand, and I was hitting balls across over the net over here to my friend who's on the other side. And the ground stroke is typically shot all around these starred areas, so along the baseline of the court. This is why you need quite a lot of power to get the ball over the net, but still land it inside the court. Now to tie things into physics real quick, I chose to use this equation of impulse equals force in newtons times time in seconds. And this relates to tennis because, like I said previously, hitting from the baseline, you're going to have to hit the tennis ball over across the net and land it in the court for it to be a good shot. And just given by the equation, we can see that as time increases or contact with the ball increases, the impulse would increase as well. So the connection in tennis would come with technique, and the follow-through is very important. It's taught from a very young age to finish with the racket above your shoulder to really teach the kids and ingrain their muscle memory that the tennis racket needs to finish high so they're able to get the ball all the way over across the net. Okay, just keep it going. Okay, stop. So now that I've identified how important it is to get the ball up and over the net, it's also important to keep it within the boundaries. That makes it a fair shot and forces your opponent to return the shot with a fair shot themselves. This is where the Magnus effect comes into play, and that's how physics is related to tennis as well. So as you can see in the diagram here, if the racket is being held here by you, and the ball is being shot this way with this velocity vector, by hitting backspin or a slice, you can see the higher air pressure is created below the ball and the lower air pressure is created above the ball. And the force, the Magnus force, causes the ball to lift up. Now I'll show you guys examples of this, but the same works in reverse. If the rotation of the ball is going in the opposite direction, that's what's called topspin, and the higher air pressure and lower air pressure would be switched, and the Magnus force would come down. So this helps tennis players hit the tennis ball hard with lots of impulse, but keep the ball from flying out of bounds. Yeah, just went straight, and this one's going to have some topspin on it. Yeah, that was good. So hopefully these few examples that I brought up, including physics terms, is able to answer the initial question that I presented to you guys of how physics is involved in hitting ground stroke shots in tennis. Hope you guys enjoyed. Take care.